All right, well, my name is Frank Pendleton, and I'll be giving you a little talk about data sets. I'm the GIS specialist at BOEM. Wait, got something popping up here. There we go. All right, I'm the GIS specialist here at BOEM, and for those of you unfamiliar, it's basically computer mapping. So I'm going to talk to you a bit about a few different data sets, show you some samples, some of the things we're using, and just how some data sets are developed. So next slide, please. All right, we'll start with wind. We're looking at offshore wind. So this data set we get from NREL, the National Renewable Energy Lab. And this is just a subset of a bigger data set they have called the Wind Toolkit. And it's available on their Wind Prospector site. And if you look at this data over on the right, you see the different colored polygons. That's the average wind speed for all those areas for the year. And this is in meters per second. And what you can see is the gray is the places where the wind is too slow. And you can see a bit of that down by San Francisco and a bit way up in northern Washington. Oregon has good wind speed all around. But anyone who's got a kid, you show them something like this and you said, yeah, but how did you get this wind speed? So let's go to the next slide here. Right, and we're making those polygons out of these points that are created by NREL. Right, and what you can see here is the map on the right is it's a January data set, and it's all created out of points. And if you look just a little bit to the left of the map there in the legend, you'll see down at the bottom there's specific monthly offshore wind speeds. And there's data sets for every different month as well as an annual subset. So then me being much like a 3-year-old and asking questions, I said, yeah, but where did these points come from? And I asked that question to the scientist at NREL. And she first sent me some papers with a lot of calculus and other fancy words, but next slide, you can see what she sent me next. That I said, I need a picture, which I'm a simple guy. And she sent me this. And this gets to this idea we're gonna see a lot of today, is data sets that are coming from many sources and being put into one overarching data set. And this is the idea with their wind data set. They're getting wind speed data from satellite data, from weather ships, from buoys. So it's coming from all over and they're bringing it together in this one overarching data set, which is kind of the main wind data set that folks are using. All right, that's it for the wind. If you can go on to the next slide, please. Now we'll talk a bit about depth. This is the bathymetry data set, and this one comes from NOAA. And you'll see this theme. We're working a lot with different partners, different data creators who are kind of the experts in that field. In this case, it's NOAA making the bathymetry maps. So you can see the blue map there on the left, and that is just depth. We've taken it and said, where it's deeper, make it darker blue. Simple enough to follow. Depth, very important for where offshore wind can go. But then we can also take this data set and look at it just a little bit different and derive slope. So on the right, you see the slope data set. And as folks know, green are happy places and red are not so happy places. Where it gets really steep is where we've turned it red. And that's obviously a concern for us in offshore wind. It kind of gives us a red flag, lets us know there's a lot of things that could be happening in steep places. Steep places in the ocean tend to be harder. Harder places tend to be tougher places to put an anchor. Also places where you might find things like corals and things like that. So things of concern. So that's another data set, our depth and our slope. Next slide, please. This thing of obvious concern to offshore wind, where are you going to plug it in? Right? If you're creating this electricity out in the ocean, how are you going to get it onto the grid and get it to where the people are? In this case, we have the grid connection data set. It's a simple enough data set to understand where are the substations and where are the transmission lines coming from them. So simple enough to understand, but obviously very important in the planning effort. And you can see, again, this is from the Homeland Infrastructure Foundation level data. And yes, we're the government, so people tend to call it HIFLD or whatever. But you can again see, this is coming from a lot of different agencies, all reputable folks about where are these things. Okay, off to the next. Now we're going to change over to kind of a different idea, some of these example of density grids. And we're going to start with vessel traffic. So, just getting to the idea of how many
how much does this take place in an area? So with vessel traffic, we're going to look at two different sets of data. These data are both satellite tracking data. In the first case of the AIS data, the whole purpose of it is collision avoidance. And it's a Coast Guard data set. And we reuse it to find out where the boats have gone. Some boats don't need it, only boats over 300 gross tonnage. And to get that to, and something that your average person understands, that tends to be about 65 feet, right? Give or take. Gross tonnage and feet aren't the same, but it gives you an idea of the size of boats we're dealing with. And in this case, we've got data from 2009 to 2020. And this data is readily available. Anyone can go to this site here, the Marine Cadastre, and get it if you're interested. And we've analyzed all speeds. So that's one way for us to get to where the boats are. Another way is this whole different system called the Vessel Monitoring System, or VMS. And this system is created for fisheries management. And thus NOAA is managing it, particularly their Office of Law Enforcement, because it's to make sure where boats are going. Now, the folks who are required to have it are certain federally managed fisheries. And the data sets we have is from 2010 to 2018. And this is confidential data, so we have to analyze it to such and such a level before we can share it. And in this case, we're looking at just fishing speeds when we get to this. So boats that are going slower, so they might be fishing. All right, next slide. Now we're going to look at a few different sets of the AIS data and then one of the VMS. This is the all vessels. So any vessel that is required to have an AIS, this gives us kind of a look at it. And on the left side there, we're looking at the whole West Coast. And on the right side, it's just Oregon, which is kind of easier for us to grasp, smaller area, and we can kind of see the details a bit better. And so this is all ships, so no matter what they're doing out in the water. And you'll see, as you look at some of the trends you can see here, you see a couple of those two green lines all to the far left of your screen. Right, you'll see those and you can see kind of that fatter green area and you see kind of the red areas that pop out to us. And we'll see as we go through these other slides, which boats are creating those kind of high density areas. Next. So this gets us the cargo ships and we can see they're kind of staying right on that edge, that right around our 1,300 meter depth. That just gives you an idea where they fit. And obviously a lot of them coming in and going out of the Columbia River. All right. Next. Now off to the tankers. Obviously it's a bigger deal if a tanker goes ashore. So my guess is they're required to stay further off and further offshore. So if anything goes wrong. And here we can see how the tankers were those lines way far out. All right, the next slide. Now this is the tugs and tows. You can see they've got various lanes they're supposed to stay in, and they're doing a pretty good job of staying in their lanes. Because you can see like the green, that's not many ships, right? 1 to 5 ships in a year. That's not much at all. It's not till we get up to that yellow and particularly the orange where they're really using it. Next slide. Now this is going to take us into fishing, and we always have the caveat with AIS data for fishing, because what we said early on is only boats larger than 65 feet or so are required to have it. Some smaller have it, but not all. But this gives you a view into where the fishing data fit in this, that there's some particularly key spots where a lot of folks are fishing. And we're going to take this is the AIS data, right, which is designed to keep boats from banging into each other. The next one is going to be the VMS data. So let's take a look at that. And you can see how similar they are to where the hot spots are. Here we've deleted some things, we're just doing where are they fishing, where are they going at fishing speeds, and trying not to get so much of the transiting, but you can see how similar they are. Okay, now let's go ahead on to the next slide. This is getting at this same idea of where is it busy fishing, but from a whole different perspective, a whole different data set. And here we're starting with, this data is coming again from other experts, from the folks at NMFS, the National Marine Fisheries Service, and particularly their Northwest Fisheries Science Center. And they're getting at it from different data sets, being observers, state logbooks, fish tickets. That's when you land and you say, we caught so many fish of this type. So they're getting at this same data set from a very different angle, which is great. They got a lot of different information in there, but still getting the idea of where's the ocean busy.
And it's nice to see all our data sets are kind of lining up. So this is a data set. You can see this one. It's already on OROWIND. Next. And now another completely different way to get at this fishing idea. This data is part of the Territorial Sea Plan for Oregon. And they had a participatory mapping exercise where they went out and talked to fishers in different ports. And the fishers told them, these are the places that are important to us. This data is owned by the fishers and it's by port. So you can see there on the map that I've got 4 of them up there that are all overlapping by each other, but you can find out where are the important places to the different fishers by the port. Again, another way to get at this same idea of where are the busy, important fishing areas. Okay, on to the next one. Right now we're still in this world of density, but we're going to get to a whole different data set and a whole different idea. We're going to look at birds and marine mammals really quickly. And we'll start with the different, kind of the process. The first thing is, how do you get your data, about where are the birds? And then, so that's the ways to use survey. And you can survey from ships. You can, with observers on a ship, you can have observers in an airplane, or you can have airplanes taking photos that you can use later. And all of this data can be used to create a model to give us more insight. So the next slide. So to get to the aerial survey idea, so an aerial survey with an observer on board, several of these were done with the folks from USGS, so US Geologic Survey, and it was a USGS BOEM study. They did a lot of surveys off the coast of Oregon, Southern Washington, and Northern California, 2011 and 12. 6 different surveys where someone is sitting in the back of the plane IDing the birds as they fly over. Plane flying very low, getting a good idea of where all these birds were on that particular day. And you can see in the all surveyed, I'll take you to the far left there, and you can see the all surveyed. So that's all these surveys. Where was it thickest with the most birds? And then the other 6 to the right are telling you on a specific survey. And for anyone who's like an ornithologist, real serious bird person, realize we understand that lumping them all together is not how you want to look at birds. But this is just to give folks an idea of where the birds are and the types of data we have. So let's go on to the next slide. Now, another way to actually get the data is aerial photos. This is a bit newer, and it's going on now down in Southern California. And what this allows is a plane to fly really high and take pictures, which allows us to have a permanent record of what was seen. And then we can use artificial intelligence to help with the ID process. So in the top picture, you see the top right there, you see the red circle. It's a pelican inside there. And then you can zoom in a bit closer and get, okay, we could ID this bird to species. Down below, you can see the dolphin that's also getting ID'd during this this flight. One more picture, so we can get marine mammals, birds, sea turtles, lots of variety of species from the same survey. And then the box you see there on the left, this is getting to the artificial intelligence idea. So someone doesn't have to look at every single part of every picture, that IDing what is a bird, in this case, what is a sun glint? So I think you can kind of see we've got the 5 birds and 4 sun glints, and that would get us to, okay, now we know what's real data. Okay, on to the next slide, please. Now, when we can take that, we know where the birds were, and now we can start modeling it and saying, well, where are the birds likely to be, right? Because we can only go out so often and so many places. So we really need to be able to take that and model it across the whole coast. So it gets to be looking at a lot of different variables. Here's just a few of them. Like what time of year was it when we saw that bird? What latitude were we at? How north-south? How deep was the water? What was the slope? How far from shore? The currents, salinity, how green was the water? How much chlorophyll? And several other factors go into that to model where the birds are likely to be. And these are getting better and better. This data set isn't out just quite yet, but it's will be coming out soon and be very useful for looking at the birds. So next slide. And this is our last one. And you can see how we're kind of getting to going through the same process, but for marine mammals. And on the left there, you can see where the ship surveys are. And these are very expensive. So in the years since 1991 to 2014, they had done 8 surveys. There's always more going on. The models are always getting better, and new data is always being produced. So here's one. This is coming from the folks at NIMS again, and they're doing a great job with this and working with a lot of different folks to bring this data of where are the most marine mammals at different times of year in the ocean. So, and with that, I believe that's my last slide. All right, thank you.